Hey folks. Yeah. Yeah. So we are up with the intro. We are up with the IoT workshop. So we'll just go through a bit of theory. Then we'll start with the real thing. That's the live demos that we have prepared. So let me introduce you to the team. We have Yuvraj. Hey Yuvraj, can you turn your video on?
Hello
Hey.
guys.
So we have Ravinder. Hey Ravinder.
Hey,
And then we have Rahul, Sumit. So we are from DSC and Robotics Club of NIT-Jalandhar essentially, and it's
yeah,
kind of a major event in the month of learning series. So let's, without wasting any time, let's get started, right? So Ravinder will be getting us through the PPT right now. Hey Ravinder, over to you.
yes, thank you, sir. Greetings, everyone. I am Ravinder, member of Artist and DSC from NIT Jalandhar. We welcome you to this amazing workshop about Internet of Things. So let's just begin. Just type a hello or hi in the chat box to show your excitement for this session. Yep. So you guys are already excited. So let me first tell you about Artist Club. So starting. Uh, let's know about artists. So this club is official robotics club of NIT Jalandhar. We make teams to take part in competition and conduct some awesome workshops. And here comes the DSC club NITJ. It is official Google recognized club. All the reports are submitted to Google, and a lot of workshops are conducted during month of learning. And Hackmall is the famous hackathon conducted by us, which is also coming soon. So let me introduce you to the organizers of this event. Uh,
Yeah.
we have Anubhav Gupta, the DSC lead, Naz Kakriya, and Anmol Virti, members of Artist and DSC. I would like to thank them for giving me the opportunity to speak for this session. And for speakers today on board, we have with us Sumit Singh, Yuvraj Mehta, Rahul Guglani. All are the members of Artist Club. So let's start. So starting with the question, what comes to your mind when you hear the word IoT? Just answer in the chat box.
Yes. So I think IoT is something like we are controlling all the things around us in physical world using code, right? Yes,
Yep.
sensors, Internet of Things.
So
Yeah,
we have
things
got
related to
some
internet.
answers all about yes, internet.
Yeah.
So let me just tell you about IoT. Uh, how many of you are Marvel fans? Just type "Love You 3000" for Iron Man.
Yeah. Yeah.
Yeah. So hopefully you might remember this scene from Infinity War, where your friendly neighborhood Spider-Man comes into the scene. जैसे इस scene में Iron Man gives a command to Friday to send a suit for Spider-Man. So you can see in the beginning, Iron Man said unlock 17A, and this command is received by Friday at his residence, from where a suit is launched to precise location of Spider-Man. तो फिर स्पाइडरमैन उसे एक्वायर कर लेता है. तो बेसिकली आईओटी यही होता है, एन इंटरकनेक्शन जो आपस में चीज़ों का जिससे कि वो सेंड और रिसीव कर सकें डाटा एक नेटवर्क के थ्रू. सो
Yeah.
आई थिंक बेसिकली यू हैव गॉट द आइडिया अबाउट what IoT is. So let's get to the next question, that is difference between IoT and robotics. मतलब फर्क क्या है IoT और robotics में? Just type in the chat box.
Yeah. So essentially, I think the
Yeah.
difference is in the T part, right? So the T is things. So IoT is kind of soft, software collaborating with robotics. Am I right, Ravinder?
Yep. So दोबारा हम इसी सीन पर आते हैं. तो like इसमें Iron Man gives a command to Friday to activate thrusters while he was reaching the space. Then the thrusters are increased when the robotics come into play. Uh, as the suit as the suit when reaches Spider-Man, it becomes of his proper fit, and all other Iron Man suits are a prime example of robotics. Basically, the things in the term IoT, Internet of Things, the things in this term is the thing that responds to a command, and these things are basically robotics. So now you have got the idea of both IoT and robotics. So, what is the reason why you must try it? What is the reason to try it? So, the answer to this question is simple. Though mostly of our is interest driven, but just have a look at this scene. You can see how cool it looks. Everyone gets interest in these things automatically. Leaving fiction apart, daily life maybe we like smart things like smart TV recognizing hands, smart watches sensing heartbeat, and all these smart devices that made our life easier and better. All these were built by an IoT developer. Also,
Yep.
IoT is a rising field these days. Last year, 8 out of 24 projects that got selected in Imagine Cup were based on IoT.
Yep.
So, this event is gonna be really amazing. Uh, it will be a 2 day event, and where we will learn firstly about microcontrollers that include hardware, software, sensors, and code. Then we will learn about Tinkercad, where we will see some stimulations, wiring, and schematic. And the projects will be shown in the workflow to kill the boredom. So हम प्रोजेक्ट्स जैसे बीच में बिल्कुल रिलेटेबल होंगे वो जो चीज़ सीखते जाएंगे
Yep.
उसका प्रोजेक्ट साथ में दिखाते जाएंगे माइक्रो कंट्रोलर पे जो चीज़ें और सॉफ्टवेयर देखेंगे आर्डिनो आईडी वगैरह और फिर डे 2 पे जाएंगे डे 2 पे आईओटी में हम देखेंगे कि ईएसपी को फायरबेस और ब्लिंक के साथ कैसे कनेक्ट करते हैं और ये कैसे यूज़ होती है और फिर इसके बाद भी यहाँ पर हम अभी रुकेंगे नहीं नॉट स्टॉपिंग हेयर वी विल लॉन्च ए फॉर्म ए वीक आफ्टर डे 2 फॉर सबमिशन ऑफ आइडियाज then the best ideas among these will get goodies from our side worth rupees 3K. So sit tight
So
and enjoy
the
the
yep.
workshop ahead.
Yeah, go.
I'll hand over to
So
Ram.
the yeah, so the goodies will include like the real hardware that we'll use in the demonstration right here, right? So stay tuned. Hey Rahul, let me bring you to the screen. We have Rahul. Yeah, hey Rahul. So Rahul made this
Hello
cool
everyone.
project. Yeah, it's the automated door lock. Right. Yep.
So before getting started, I want to show you something. This is an automated door lock. It has an LCD screen, a keypad, and it is password protected. So here is a lock which I hacked using connecting a DC motor to it. So when we will enter correct password, it will open the gate for us. Now I am entering a wrong password, so it has shown the error. Now I will enter the right password, and it will first completely open the gate, open the lock, and then remain in open position for 10 seconds and then close automatically.
Yeah. Cool.
So how do you think it works?
So is it live or something in the PPT? Hey Rahul.
Yes, sir. So we cannot enter code directly into the lock, and we can program in computer but cannot connect lock directly to controller. So to fill in the gap, here comes Arduino or microcontroller. Let me show you this.
So let's move on. Yeah. Uh, Let me show Rahul. Just a minute. So we have Rahul here. Yep. So this is the live demonstration, folks. The lock that he made. You are not audible. Let me add you to the stream.
I'm audible?
Yep. So
सो हमारे पास ये लॉक है, हम इसको डायरेक्टली बैटरी से कंट्रोल कर सकते हैं कि अगर हम इस पे बैटरी लगा दें तो ये लॉक हो जाएगा या अनलॉक हो जाएगा। बट अगर हमको इसको ऑटोमेट करना हो तो हमको एक
just a
माइक्रो
minute.
कंट्रोलर चाहिए जिसमें हम प्रोग्रामिंग कर पाए कि हमको क्या करना है। सो
Yep.
मैं इसका कोड शेयर करता हूँ। Yep.
Yep.
So I have a function lock and unlock. So now when I will run it, it will first unlock it and wait there for 10 seconds and then lock it. Let me show.
Hey, Rahul, could you like zoom in a bit for the code? Yeah. Control plus
So
scroll.
I hope you
Control
can
and
see it.
scroll. Yep. Yeah, go on.
It is unlocked and it is waiting for 10 seconds and now it is automatically locking. You can see.
Yep. Yeah. Cool, cool. Let's move on.
Uh,
Yeah.
okay. So I hope you can see this.
Yep. So just look how the motor is running and it's opening and closing the door hinge.
And it is waiting here for 10 seconds and then it will automatically lock and then wait there for 10 seconds.
Yep. Yeah. So
Okay.
let's move back to the
So
PPT. Yep. So over
so
to you.
have you ever thought how can we control electrical appliances using microcontroller? So first of all, let me tell you what is a microcontroller. So in this project, as you have seen, that it is a small computer that can be programmed and can perform certain tasks. Like we can use microcontroller in various scenarios, like to control door, to control lights, and to automate anything. There are many type of microcontrollers in the market. So here are some. It is this one is Arduino Uno, which is the most common one and can perform most of the functions. And here comes Arduino Mega, which has much more pins and processing power. Like अगर हमको कोई प्रोजेक्ट बनाना है जिसमें ज़्यादा प्रोसेसिंग पावर या पिन्स की ज़रूरत है, जिसमें हमको ज़्यादा सेंसर्स वगैरह यूज़ करने हैं, तो हम Arduino Mega यूज़ करते हैं। And this is
Yeah.
ESP32. It is a wireless board actually. So we can control this using Wi-Fi. We use this in IoT projects. Like कि हम फोन से कंट्रोल कर सकते हैं चीजें एंड इसमें भी हम प्रोग्रामिंग कर सकते हैं। ये सिमिलर है आर्डिनो की तरह बट इसमें हम वायरलेसली भी कर सकते हैं। So this is Arduino Uno. Like I have shown in my project, I have used it for the door lock. So this is how it looks, and this is its diagram. So it has an USB port, which is connected to a computer for programming, and a power jack. like uh, क्या होता है कि जब हम इसमें प्रोग्राम करते हैं तो हम प्रोग्राम कंप्यूटर से करते हैं, लेकिन जो कोड रन होता है वो इस माइक्रो कंट्रोलर के अंदर होता है। अगर हम कंप्यूटर से हटा भी दे तब भी इसमें इंडिपेंडेंटली प्रोग्राम रन होगा। अ, और ऐसे ऐसे केसेस में हम इसको एक्सटर्नल पावर देते हैं। तो ये जो पावर जैक लगा है, इससे हम पिन लगा के इसको पावर दे सकते हैं। एंड ये 5 वोल्ट लॉजिक वाला है, मतलब जो इसकी पिन्स होती हैं, हियर इट्स जीपीआईओ पिन्स, दैट मीन जनरल पर्पस इनपुट आउटपुट पिन्स। ये यूज होती हैं प्रोग्रामिंग में कि हम इससे चीजें कंट्रोल कर सकते हैं, इसमें इनपुट ले सकते हैं। जैसे स्विच इससे कनेक्ट कर सकते हैं एंड पता चल जाएगा कि हमने स्विच ऑन करा है ऑफ करा है, एंड उस अकॉर्डिंग हम प्रोग्रामिंग कर सकते हैं। सो लेट मी शो यू समथिंग। So here we have Arduino. Okay, let me do a little setup.
So meanwhile, Rahul does his setup, so we can like move up and do ping us like Rahul in the chat box like when you are ready. Yep. So we have Ravinder. Who's speaking now? Yeah.
Okay, so I am connecting relay to the Arduino, so we can control things. So अभी मैं आपको लाइव डेमो दूंगा कि हम Arduino से होम अप्लायंसेस कैसे कंट्रोल कर सकते हैं। इसकी
Yeah.
जनरल पर्पस इनपुट आउटपुट पिन से हम उसमें प्रोग्रामिंग करेंगे एंड उससे एक लाइट ऑन ऑफ करके दिखाएंगे।
Yeah. So meanwhile, Rahul prepares this demo. Like we can go
Yep. Sir.
about
We have these RX and TX LED where when we upload the code, both of these continuously blink, and then we have pin 13 when the code is running in a loop. Then this turns on, and we have PWM pins here, the digital pins, and this is a ground pin here, and two ground pins are located here. So these act as negative. We connect it to the breadboard. Here. So these are the analog pins. Uh, these are variable. These have the variable output graphs, and these have the digital graph. We will show.
Yep. So we have some doubts in the chat box. So Ashutosh is asking like which coding language is used. So in IoT we can use either Python or either like C, C++. The Arduino is basically programmed using C++. It is like a superset of C, like, with its own native libraries, right? We'll just show you how to program. Ankur is asking for basic requirements for IoT, right? So for basic requirements, you must have some hardware. So like without hardware, you cannot like experiment and play with things around. But once you have hardware and some knowledge for pins and stuff, like you will be good to go as a IoT developer. Yeah, Ravinder, could you answer this? Like Nikhil is asking, what is the difference between digital and analog pins? Like, yeah, Ravinder.
Yep. Sir. So
Okay, so
okay, I will hand it over to Rahul.
let me explain you what is the difference between analog and digital pins. Actually, the digital and means it has two states, either on or either off. So we have seen the general purpose IO pins and Arduino. लाइक उसमें जो पिंस होती है उसका आउटपुट होता है या तो 0 वोल्ट या 5 वोल्ट। 0 वोल्ट मतलब ऑफ, 5 वोल्ट मतलब ऑन। जैसे हम कोई भी चीज इससे कंट्रोल करते हैं तो इसी लॉजिक से होती है, डिजिटल लॉजिक से। एंड जो एनालॉग पिंस होती है उसमें सिर्फ ये दो नंबर नहीं होते, उसमें रेंज होती है। एंड जैसे उसका ग्राफ कंटिन्यूस होता है, इसमें तो जैसे आप देख रहे होगे यहाँ पे ग्राफ बना हुआ है। जो डिजिटल लॉजिक है इसमें, उसमें दो ही स्टेट्स है, या तो 0 या 1। एंड जो एनालॉग सिग्नल होता है उसमें काफी सारी वैल्यूज होती है, सिर्फ दो वैल्यूज नहीं होती। एंड जो हमारे पास आर्डिनो ऊनो है, वो उसमें जो वैल्यूज होती है वो 0 से लेकर 1027 तक जाती है, मतलब कि 2 10 तक जाती है। सो मतलब कि उसमें वेरिएबल वैल्यूज आ सकती है, एंड डिजिटल की सिर्फ दो ही वैल्यूज होती है, 0 और 1। जो एनालॉग पिंस है आर्डिनो के अंदर, वो सिर्फ रीड का काम करती हैं। एंड आपने कहीं पे देखा होगा, या भी हम आगे डिस्कस करेंगे, कि जो हम उसमें फंक्शन यूज करते हैं डिजिटल राइट आर्डिनो में, वो बेसिकली होता है डिजिटल पिंस के लिए होता है। वो एनालॉग राइट फंक्शन डिजिटल पिंस के लिए होता है। उसमें क्या होता है कि हम बहुत जल्दी जल्दी डिजिटल पिंस को ऑन ऑफ करते हैं, तो उससे हम उसको पीडब्ल्यूएम बोलते हैं, कि पल्स विथ मॉड्यूलेशन, एंड उससे हम सिग्नल्स प्रोवाइड करते हैं। एंड इसमें सारी पिन्स पीडब्ल्यूएम नहीं होती, कुछ पिन्स आर्डिनो उनो के अंदर पीडब्ल्यूएम होती है, जिससे हम पीडब्ल्यूएम पिन्स की हेल्प से हम ब्राइटनेस और मोटर की स्पीड वगैरह कंट्रोल कर सकते हैं। कि अगर लगातार उसकी वैल्यू +5 होगी, तो मोटर फुल स्पीड पे चलेगी, लेकिन हम उसको कुछ ही स्पीड से ऑन ऑफ कर रहे होंगे, तो मोटर की स्पीड थोड़ी कम हो जाएगी। सो ये बेसिकली उसका वर्किंग होता है।
Yes, so let's move to sensors now. Ravinder? Yeah. Yep. So,
So we have Sumit to explain about sensors.
yes, Amit. Yes, Amit.
Hi. So I'll be talking about sensors. So first of all, without getting started, I would like to start with the fact, like in our day-to-day activities or day-to-day life, we come across many components and many devices. For example, us human beings, we have a complex network of sensors like eyes, ears, and other sense organs, but we generally have a tendency to ignore them. So similarly, robots have sensors like ultrasonic sensor that is analogous to eyes of human. So in the next slide, there are few sensors that are very commonly used in building robots. So next slide, please. So these are few sensors that are really interesting to learn about. So the first one is ultrasonic sensor. You can see that it behaves and it looks like a human eye. So basically it's used to calculate distance. Then we have IR sensor. IR sensor, the full form is infrared sensor. So the main purpose of it is to detect the heat waves that any object is releasing. We can use it in projects like where we have to detect heat and make fire alarm. Then we have the light sensor that depends on the intensity of light that is falling on an object. So when the intensity falls, it turns high, and when there is darkness, like there is no light source in the room, then the LDR or the light sensor turns to 0. And in the next slide, there are yeah, so there are more sensors that we can talk about, like sound sensor and temperature sensor. So basically, these sensors, I hope that are understandable by the names. I would like to talk about gyroscope and accelerometer here, because these sensors are really really well in the drone sector. For example, the leading drone manufacturer like DJI, they uses gyroscope and accelerometer in their drones. And in next slide, please. Now let's learn about actuators. So basically, actuators are electrical components that are used to convert electrical energy to mechanical energy. They basically turn any component either on and off. For example, like we have switches that can turn on and off any object, but then actuators, they move things. So next slide. तो इसमें आप देख सकते हो हमारे पास 4 डिफरेंट एक्चुएटर्स हैं, लाइक सर्वो मोटर, जो कि किसी भी ऑब्जेक्ट को एक पर्टिकुलर एंगल पे रोटेट करने के लिए यूज होता है। देन वी हैव डीसी मोटर, जिससे हम लाइक अपने चाइल्डहुड से अपने आरसी कार्स में देखा होगा कि ये बहुत हाई स्पीड पे किसी ऑब्जेक्ट को रोटेट करने के लिए यूज होता है। देन वी हैव स्टेपर मोटर। स्टेपर मोटर उन केसेस में यूज होता है जहाँ पे हमें टॉर्क की बहुत ज़्यादा रिक्वायरमेंट होती है, एंड साथ ही साथ प्रिसीजन भी बहुत ज़्यादा हमारे लिए इम्पॉर्टेंट फैक्टर होता है। तो स्टेपर मोटर को हम अपने रोबोटिक आर्म्स जो कंपनीज बनाती हैं वो लोग यूज़ करते हैं। एंड देन वी हैव लिनियर एक्चुएटर। तो यार अभी तक हमने देखा कि हमारे पास मोटर्स थे सिर्फ, जो कि सिर्फ किसी ऑब्जेक्ट को रोटेशनल मोशन दे सकते हैं, बट समटाइम्स हमें अपने प्रोजेक्ट में लीनियर मोशन भी प्रोवाइड कराना होता है। फॉर एग्जांपल इन द नेक्स्ट स्लाइड आप देख सकते हो, यहाँ पे हमारे पास एक रोबोट है जो कि वेयर हाउस में ऑब्जेक्ट्स को ऊपर से नीचे रख रहा है। एंड इन द नेक्स्ट स्लाइड हमारे पास एक 3D प्रिंटर है जो कि लेफ्ट और राइट मूव करके एक अर्थ का मॉडल प्रिंट कर रहा है। सो इन केसेस में हम linear एक्चुएटर यूज करते हैं। And now I would like to show you a project that I made myself. So this is a project based on the ultrasonic sensor. I would like to share my screen if possible. Hey guys, can you please confirm if my screen is visible?
Yeah, it's visible.
Okay. So let me also turn my camera. I hope my setup is quite visible clearly.
Uh, just a minute. So let me focus on the camera first. Uh, yeah. Yep.
Okay. So this project is made using the ultrasonic sensor, that is this one, and an Arduino Uno. So this project is distance versus time graph project, in which the ultrasonic sensor is plotting distance based on the time in with units of seconds. So let me show you a live demo of how it's work.
So
So guys, can you see the graph that is being plotted?
I'm afraid it's not visible. Yeah. I think you need to like share your whole screen essentially. Yep.
Is it now?
Nope. So what it does is like it is plotting a real-time distance graph like that. So it will show you right now. So whenever something comes near to the sensor, it just changes its distance value. So you can measure distance in centimeters or meters the way you code it. Right? It's like a sonar basically. So yeah,
So when I move any object in front of this sensor, we usually get a graph that is on the x
yep.
and y coordinates. Uh, I don't
So
know why things have messed up and my graph is
yep,
not visible.
sure. So let's move with the current flow in the PPT. Yeah. So I'm adding Ravinder.
Yep.
Yep. So let's talk about
So we have
microcontrollers.
Yuvraj for explaining about microcontrol computer.
Yep. Here Raj. Yep.
Hello, sir. Hello, guys. So basically, now we'll
Can
talk
you
about
turn your
micro.
audio on? Like so speak more loudly. It's not that audible.
Wait a second. Am I audible now?
A bit more louder.
Hello, sir.
Yeah. Perfect.
Yep.
You can
So
go ahead.
now we'll talk about microcomputers. So like राहुल ने तुम लोगों को माइक्रो प्रोसेसर एंड माइक्रो कंट्रोलर के बारे में बता दिया, लेकिन दैट वी यूज द सेंस एंड सुमित ने सेंसर्स के बारे में बताया इन विच वी टेक डेटा फ्रॉम द एनवायरनमेंट एंड गिव इट टू माइक्रो प्रोसेसर and microcontroller to perform such tasks. But for example, अगर तुम लोगों को एक high computing power चाहिए होगी, because in the microcontroller there are like in Arduino there is like only 1K EPROM data memory storage type something. But in इसके उनके इसमें you cannot हम कॉम्प्लेक्स कोड्स नहीं यूज कर सकते लाइक तुम एक कैमरा लेके उसके अंदर से वो वीडियो रिकॉर्ड कर सकते हो बट यू कैनॉट यूज ओपन सीवी एंड अदर complex code in it. So there come the microcomputers. So microcomputers basically वही हैं जिसके अंदर हम हाई मतलब complex code यूज कर सकते हैं. So now here in the screen this is a Raspberry Pi 4 PY4. So दिस इज एन माइक्रो कंप्यूटर बेसिकली यू कैन सी. अब तुम लोगों ने माइक्रो आर्डिनो देखा था, उसके अंदर एक दो यूएसबी पोर्ट थे and बाकी पिन थी. बट यू कैन सी हेयर देयर आर मैनी female mounts like HDMI female mount and USB mounts are there and many other mounts. So these can be used for various purposes. Like please next screen. Okay, sorry. So
So
now we'll see some of the hardware. Like अब तुम लोग photos वगैरह तो देख लिया, so now we'll see some hardware unbox that will show you.
yep, folks. So I have this setup essentially for the workshop right now. Yeah. So let me just share my screen. So is my screen visible? Right. So this is the most favorite guy right here. This is called Arduino Uno, right? So let me zoom in a bit. So this is Arduino Uno, the microcontroller we are talking of. This is a smaller version of Arduino. This is called Arduino Nano. So it comes with these pins. So we'll just have to solder these pins in these headers and it works. So we'll be giving away two of these Arduino Nanos. And if we get a really good, if we get a really good input from you guys, we'll be also giving Arduino Uno, right? So this is the Arduino Nano. Coming to the microcontrollers, this is the ESP8266. So I used it for a water tank project, so it's a bit trusted here. I'll have to just replace the pins. So this is essentially the Wi-Fi module. Like inside this particular thing, there is a Wi-Fi connection chip. So this connects to the Wi-Fi and works. So we can control things from anywhere in the world, right, over the internet. So this is the main thing that we'll be covering tomorrow for the IoT thing, right? So this is kind of my personal favorite and quite rugged the chip, right? So coming on. So this is the cool baby. This is called Raspberry Pi. So if I show it tear down to you, so the fan is to cool it. It works. So believe me, it is a computer in its whole like setup. So it's kind of, you can keep a computer in pocket. It has around like 1 GB RAM, and instead of a hard disk, it runs on this particular chip. So it has a OS. It runs on Linux, so you can do programming, you can make projects, you can do any kind of stuff you can do on a normal computer. So it works, right? I hope it's quite visible. So just see the detail like PCB. So this is a Raspberry Pi. You can connect with like cameras. You can connect. You can. These are the GPIO pins. It has 40 pins in here, right? So these pins work really cool, and it works on 3.3 volts. So you just plug in the charger, and the pins work on 3.3 volts essentially, right? So let me just put this aside. I'll show you this working at the end. So what next we have in our inventory? So we talked of actuators. So before talking of actuators, we have this thing. This is the Arduino Shield, right? So this is like L293D. So it is a H-bridge MOSFET. So uh, just do away the fancy terms. What it does is, like, we have a motor. So we need to drive a motor. The motor has to be driven using a high current. So this little thing Arduino, this poor guy cannot give you the current to drive a motor. So if you need high current, but you have to process the signal from Arduino, what do? You use this kind of stuff. This is called the driver ICs. So this picks up signal from Arduino and use an external power supply to run the motor. So we'll show you how it works. So it, like, you just fit it on the top of Arduino and it works like this. It goes on the Arduino. Yeah, essentially like this. So that's why it is called the shield. It is called Arduino Shield, right? So moving on quickly to the other parts. So let's come. This is also a motor driver. This is like a more heavy duty motor driver. This particular thing is called heat sink. So the ICs dissipate a lot of energy in terms of heat. So to keep them cool so that they don't burn. So we use heat sinks. So these are kind of generic heat sinks we use on our ICs. So we just cut a piece of it using a saw and we like use a thermal paste. Let me show you. So this is the thermal paste essentially. We use this to like fix up heat sinks on ICs. So this is my pipe. Yeah. So just see this out. These heat sinks, I made these myself. Like these heat sinks, I made this myself, cutting this big one. So I just stick it there using thermal paste so that it remains cool. So more the cool it is, the better it will give me the performance, right? So let me just reorganize stuff here. Moving quickly, coming to the sensors part, this is the ultrasonic sensor that you saw. So what it does is it sends a signal. There is a transmitter and there is a receiver. So it sends a signal goes and bounces back and returns to the receiver. So it calculates the time that goes between the pulse and we get the uh, distance essentially. So this is the same thing that you have like studied in your probably 8th class or 9th class, like how a sonar works, but in the real life. So you can implement. So probably we'll also add this in the giveaway if we get a good response, right? This is something like more precise and more closer version of ultrasonic sensor. This is called an IR sensor, right? So instead of doing a sound wave as the ultrasound works, what this does is it sends an infrared signal and it works on really close proximity. So you must have seen like whenever you pick a call and you keep it like near your ear, the screen goes off. So that is the ultrasound, the infrared sensor working inside your phone. Like there is always a hole in always opening near the camera. Like that's not the camera, but this sensor in there. So this is it. So I think we have gone through Arduino Nano, this little thing, and this essentially gets mounted on the breadboard. What's next in my inventory? Yeah, so this is the gyroscope. We can use this to make drones essentially. Like it can give us a rough idea of what the orientation of a particular thing is. Like if we tilt it this way, it will give a different signal. If we tilt it this way, it will give a different signal. So it comes with these headers. We'll have to solder it like this. So if you know the soldering, like soldering is like we have welding it on the pads. So there are. Let me focus my camera once, and just keep spamming the chat box with all the questions that you have. Right. Let me zoom it a bit. So and I'll have to focus it. Yeah. So let's take this away. Yeah. So this is the gyroscope. What next? So coming to the actuators part, this is like the biggest servo motor that I have. This works really precise. It has to be programmed. It does not run like I cannot plug in power and it runs directly. So it has to be given a particular signal that is generated through the Arduino using programming, right? So it has multiple steps. So essentially, it's mentioned like how many steps in a one revolution it has. Uh, it's like 7.5 degrees in one pulse, so it moves in a very precise manner. So this particular motors, like this is also a stepper, smaller one. This is just a minute. So this is also stepper. So this works in 3D printing and stuff because they need a really high precision of the head that moves and print stuff. So I also like broke my old printer and got this from that, right? This is a DC motor. You must have broken your toy cars and got this. Let me just refocus the camera and probably zoom out a bit. Yes. So moving on to see more hardware. This is the relay. So let me just focus once more. Yeah. So this is a relay. So what a relay does is relay takes a signal and it has a magnetic spring inside it, like a magnetic linear actuator. So when it gets voltage to a particular end, it closes and it behaves like a switch. So what we can do is we can give it a signal from Arduino, essentially like Arduino or any microcontroller that we showed you, be it like ESP, be it like a Nano or Pi or Arduino. We can use all this to give a signal to this, and this can control like really high voltage things. It can like control just a minute. So 240 volts, right? So it can control live AC wires and stuff. You can you make a home automation project using these stuff. So this is not used as it is, but it is used in relay modules essentially. So I have a relay module right here, right here, but I'll show it you in another demonstration. But because it is wired, into a project. So this is a linear actuator, this thing. So it has a magnetic coil inside it, and it has these wires. These wires, yeah. So that it has a magnetic spring inside it, and these are wires. So whenever the wire gets current, so the spring should like retract itself. So it is used in making locks and stuff, because like in normal way it's like this, but when it gets some voltage, so it will like move in. So let's try it out. So let me put it right here. This is the 12-volt supply. So let me just, yeah, see, see. Let me just like use a make a coil gun out of it essentially. Yeah, see, it's retracted by the magnet, but there is a spring inside it. Whenever the circuit breaks, it jumps out. So that was the actuator. This is a moisture sensor. Yeah. So how this thing works is, it has a L357 IC in here. It is called a variable resistance. So if you are in your first year right now, like probably in this semester or probably in coming semester, you will be studying digital electronics. So you will study about comparators essentially. So comparators are comparators, as the name goes, they compare the voltage around two ends. So this is a resistance essentially, a resistance measure, because we just put it in the soil like this. We just like bury it in soil midway, and the moisture content of the soil generates a particular amount of resistance, and that resistance goes to the comparator. It compares and generates a voltage signal that goes to our Arduino or ESP, and we control stuff. So when I was in my first year, I made a project like controlling the farmers irrigation stuff using this particular thing. What I did was I used this baby, this, and I used a relay. This. So how it essentially worked was, when there is a moisture content goes high, it gives a signal to this thing, and using some basic code like 10 to 15 lines of code, what we do is we just process that signal and check the moisture level in the soil. So if there is high moisture, what we do is we give relay signal to stop the pump. If there is low moisture, we give relay signal to start the pump, and it starts the pump, and things go la la land. Yep. So I think that's all in my inventory. I also had a PI sensor. Like I am unable to find it right now. This thing is so cool. This thing is used, like you must have used print statements in your code to debug stuff, right? How many of you like do print or console.log here to debug? Like I am here right now in my code. So this is the debugger for robotics. So this is a multimeter, and you can like measure voltages, current, or check continuity of a circuit. So this is used for debugging stuff. So that's all we have in hardware. I guess we can continue without taking much time. Let me see. Yeah, this is the cool thing I forgot to mention. So yep, this is a techie module. So I plan to make a like local AC, because our college do not like allow to have ACs in hostels. So just a cool fan that can give me cool air in winter, in summers, not in winter, right? So it works both way. It can be used for winters also. So if we like, let me plug it in the power supply. So if we plug it in power supply, it has semiconductors inside it. So the one phase will get really cold, and the other phase will get really hot. So we just need to put a fan over it, and it works like you can keep it on your table in hostel, and it's good to go, right? So I have a couple of these, and I was planning to use it, but never got a chance because COVID happened, right? So I think like we can continue with the normal flow of the workshop right now. I hope I didn't take much time. Yeah. So who's next?
Okay, so
Yep.
I have done the setup, and this is the relay which Anubhav sir showed us. So, and here is the relay
Yeah,
module.
it's a good. It's
So
a cool color. Yeah, I need that. Right. All my relays are blue.
it's yellow, and that one is black. So another color. So now I have programmed it, as you can see in the code. Can you please? Yes. So, so what I have programmed is I am turning on the relay for 2 seconds and then turning off it for 2 seconds. So now if I switch it on, we should see this light bulb which works on AC 220 volt. Uh, जैसे कि आर्डिनो में जो हमको ये देता है जनरल इनपुट आउटपुट पिंस में जो आउटपुट देता है वो 5 वोल्ट का होता है, लेकिन हम उससे ज्यादा करंट ड्रॉ नहीं कर सकते, वो सिर्फ सिग्नल होता है, तो हमको कुछ ना कुछ यूज करना पड़ता है। तो अभी हम इसमें रिले मॉड्यूल यूज कर रहे हैं, इससे हम 220 वोल्ट से एसी की चीजें चला सकते हैं। सो मैं इसको स्विच ऑन कर रहा हूँ। सो जैसे 2 सेकंड के लिए ऑन रहेगा, फिर 2 सेकंड के लिए ऑफ, फिर 2 सेकंड के लिए ऑन, फिर 2 सेकंड के लिए ऑफ। हम इसमें कोड में कुछ चेंज करके देखते हैं। जैसे मैं इसको 1 सेकंड के लिए ऑन एंड 10 सेकंड के लिए ऑफ करता हूँ, और लेट्स से 5 सेकंड के लिए ऑफ करता हूँ एंड अपलोड करता हूँ। सो ओके, ओके। सो अभी इसमें कोडिंग हो रही है, अब हो गई है। अभी 1 सेकंड के लिए ऑन हो रहा है एंड 5 सेकंड के लिए ऑफ रह रहा है। हम इसको जैसे सेंसर्स के साथ भी मर्ज कर सकते हैं, कोई पीआईआर सेंसर लगा सकते हैं। जैसे कोई बंदा रूम के अंदर आएगा तो लाइट अपने आप चल जाएगी एंड जाएगा तो बंद हो जाएगी, एंड इस तरह से हम कोई भी ऑटोमेशन कर सकते हैं। सो इट वाज अ वेरी सिंपल प्रोग्राम बट मे बी यूज्ड। ओके, सो अब रविंद्र हमको टिंकर कैट वगैरह दिखाएगा,
So
सिमुलेशंस।
Ravinder is going to show us some simulations on Tinkercad that you can also make these kind of simulations and submit at the end of the week, like the coming Sunday or probably. And we'll be happy to give away all this hardware to you. Like we'll just post it to your home doorsteps. So it's a giveaway from our sides to our juniors. Yeah,
Yes.
Ravinder. Yep.
So, Tinkercad is an online simulation platform where you can try out your circuits and don't lose the money on of spending on these things like LEDs sometimes burst and other things. You short circuit your circuit or these failures happen. Uh, so first of all, let me show you some simulations. We will visit the site Tinkercad. Here you can easily sign up and you can easily sign up with Google. After that you can go to your profile tab and just create a new click on create a new circuit to create a new circuit. But I have already made some, so let me show you by simulating them. So here is the code for this circuit. You can just write the code simply here and so you can see the LEDs will turn on one by one and then they will turn off one by one. So this forms a cool pattern and you can alter anything like these are LEDs in a for loop. So for loop is running from 5 to 6. These are the pins 5 to 6, 5 to 11, 5 to 13, and we are just increasing the brightness in the for loop uh, by this part of the code, and we can just delay these things like we can add first we have to stop simulation to change the code. So delay 10, delay 10. This will take much longer to turn on each LED. So you can see this. So now each LED is turning on after a bit of delay. Uh, so let me show you this project as a live example also. Just wait a second. Yeah, my camera is set up. Can you show my camera? So this is the Arduino ID where I have written the same code. Just the thing is I have just used two LEDs, so 5 to 6 I am running the for loop, and again the same code is being used and the LEDs are getting turned on. Let me just show you. So firstly this is on. Now that blue one turns on, then the blue one will uh, get turned off, and then the yellow one again turns on and off. So this is a simple code that we have uploaded from the Arduino IDE. This was the code. This was the Arduino IDE. And we have some other projects also on Tinkercad. It's a bit slow side sometimes because of heavy circuits and all the other stuff. Uh, so let me show you a simple logic and gate.
Yeah, we'll be building this right now, like in 5 minutes on the real physical platform.
So here is an logical AND gate where we have two push buttons, like the one will return one, otherwise at all other cases it will just not turn on the LED. So if I start simulating here in Tinkercad, I have only one pointer, so I will try to push the two buttons together. It will be for just 1 second if possible.
No issues, like we'll show it like live, because we cannot have like two mouses that
Yep.
can
So the
two
LED is
cursors
on.
clicking simultaneously to turn the LED on.
Yep. So sometimes it turns on because if we do it quickly.
Yeah,
So
so
here is
that's
the code
the
where the button state one is giving is picking this digital read one, and further if both the button states are equal to one, then the digital write will make it this 13 digital write to be one. Uh, so this circuit will get complete and the LED turns on. So first we will build it offline, practical. Yeah.
yeah. So should I like move ahead with my here, Ravinder? Yeah. So yeah. So this is Tinkercad essentially. You can like start building stuff and like showing us. It's already an hour and we're running out of time essentially. So let's quickly come up with the session, like the demo session I made. Uh, is my screen visible? Like this thing. So just grasp this thing once, like get a feel how your code that you write works in real world. That's the motive behind this session. Like we are just there to make you understand like the code that you are doing in the computer programming language, be it any language, so that can control things in the real world. That's not limited to your computer. You are just not forcing electrons to do math, right? So just a minute. So is my screen visible? Like, is the code clear? Just give me a hi. Anyone from the team or from the chat box? Hello. Yeah. So my screen is visible. So what we have here is we have int fire. Fire is like a sensor. So what we are doing is we are using an infrared sensor that, like, because we all know the fire is infrared radiation after all, right? So we'll be catching the infrared radiation of fire in a sensor, the sensor that I showed you, this one. So this fire is pin number 8. These are the numbers of pins on Arduino Uno. So the pin number 8 is fire, right? So we have just declared a variable. So, and we have a fan on pin number 8. So the fan is the actuator that we are using here right now. So the void setup thing, this is just to declare what pin is doing what function. And this fire state, it is also variable to maintain the state of the pin number 8, essentially. So we are declaring like pin mode. Pin mode is the like built-in function for Arduino library. So we are declaring that fire is input. Like we are taking input from pin number 8 and the fan is output, right? So we are just a minute. Yeah. So the fan is output, right? So it is giving output. So we have loop, void loop. So this loop keeps on running as long as the Arduino is on, right? So if the Arduino is on and it is connected with power, this loop will constantly keep on running and checking the state. So fire state is digital read fire. So we have pins as we discussed in the Arduino. The digital read fire means like we are reading the state of fire. If the signal is true, if the fire is true, like if there is fire, this will like get high, this will get a value high. And this is a simple if else block. If you have studied programming, just started programming, even like in a day or two, you must have studied like if and else declaratives. So if fire state is high, because like if there is fire, agar aag hai, so we'll digital write fan low. So this low is there to trigger the relay. I showed you the relay part. Just a minute, where is the relay? This thing. Yeah, this thing. So when it receives the low signal, it turns on a thing. And when it receives, I need to share my screen. Yeah. So when it receives a high signal, it switches itself off. So let's see how it works physically. So I've uploaded it like already in my Arduino Uno. Arduino Uno is connected using this cable to the laptop, and right. So this is the infrared sensor. So just ignore this particular thing. This is like useless, not useless, but not used right now. So this is the infrared bulb that will detect fire. There are three pins here: ground, VCC, and output. So the ground is connected to the ground part. Uh, the ground is connected to the ground is here, this blue wire going on, this yellow is the VCC, the 5 volts, the power, the positive one. So the positive one is connected, the positive one is also connected to the relay, and the relay is also connected to the ground. So ground and positive are essentially connected in common to Arduino, relay and the sensor, right? So this is the relay module. This was the relay. This was the relay, and this is like fitted in a module for easily making connections and for some security reasons. So Mr. Phoenix is asking like, can you do it with Java? Actually, the Arduino is essentially built over C++ thing because it uses native libraries, but there can be some like a wrapper of Java that can compile the code, compile your Java code to C++ essentially, because something that it's like the language is not a reason. The availability of libraries is the reason. I do not know like if there is any library that compiles the code to something that Arduino understands, right? So this is a fan right here, because I know like giving air to fire is essentially bad, but I cannot like do a water sprinkler example right here and destroy all my hardware that I've collected over like 3 years or 4 years essentially. So this is matchstick. Let's make some fire. So fire goes here. What's the issue? So just a minute. I'll have to fine tune it a bit. So this particular thing, just a minute. So this, yeah, this thing, this is a variable resistance. So it has three legs. Like it can be turned using a screwdriver or something like this to change the resistance. So changing the resistance will like tune the sensitivity of this particular thing, right? So let me just tune it once. Yeah, so it's tuned, I guess. Like it's at the most sensitive part right now. Let's make some fire. It detects fire and turns on the fan and like tries to extinguish the fire, but like the fan is not that powerful to extinguish the fire instantly. So let's try it once more. So see, the light blinks because it is detecting fire. So whenever I am not doing any hack or like magic, but it's all code that runs on hardware. Yeah, so this light turns on essentially when the sensor sees some fire. When the fire is detected, the light turns on, the fan tries to extinguish it, the fire goes out, right? And that's the thing. Like this is how you can control real world things using sensors and actuators. So this is our actuator right here. This is the driver essentially. It is like because the fan is working on 12 volts and Arduino gets fried up after 5. You cannot like use 12 volts from Arduino, and this particular thing is the sensor here. So I hope you understood this thing. Yeah. So coming to the next example. So let's look at some more hardware I missed when last time I uploaded. These are buttons, the small quick click buttons. Yeah. And we also have this thing. This is the LDR. This is essentially called a light dependent resistor. So the amount of light that is falling upon this interface, it will change its resistance, and we can use it for like detecting light. These are diodes. You must have studied these in your class 12th if you have like studied micro like semiconductors and stuff, the modern physics part. This is a Zener diode that goes avalanche breakdown thing. I don't clearly remember. The most hated thing of class 12th physics, transistors, like too complex to understand at that point. And this particular thing, right? So this is a transistor, the transformer. So it like transforms 220 volts AC to 12 volts. So there are three wires here. Three wires. So the three wires here means it is a center tap transformer. So you must have studied that. Let's move to another demo. Do let me know if the team has like something else to show or I can continue. Hey, Ravinder. Let me add you.
Yes, sir.
Yeah. Do you have something like to
So,
show or can I continue?
Yuvraj has to show Arduino IDE once how to
Yep.
install and set up it.
Sure. So Yuvraj is going to like explain you how you can set up Arduino IDE and stuff, and we'll like move through a new example. And there is a small task that you can do right now and like make your chances to the giveaway. We'll be essentially giving away like these sensors, Arduino Nano, and some more wires and stuff. Like these are jumper wires used for connections essentially and stuff like. So over to you, Raj, till I prepare my next demo.
Hello guys. So, like Anubhav sir and all other team members have shown you the projects, but you were wondering like where we have to write the code and how can we write the code, right? So for that we are using Arduino IDE. So first of all, installation and setup is like easy one. You just have to go to arduino.cc website, and there you can download it for Linux, Ubuntu, Mac, and Windows, and even you can get this software on the Windows app, Windows Microsoft Store also. So basically, it is a simple installation. Normal जैसे सॉफ्टवेयर इंस्टॉल करते हो वैसे होता है. So the first peak is this one. मैं I'm going to share my screen to show you. Just a second. My screen is visible. Okay, well, so first of all, this is the basic interface. Basic interface in this you have Arduino IDE basically is used to program the board. Like you can ask, like we have one another IDE with तुम बोल सकते हो ना कि like you have a VS code और तुम लोग के पास atom भी है तो why can't we program in that IDE? तो बेसिक उसका सबसे बढ़िया आंसर यही है क्योंकि Arduino IDE के अंदर हमें सब कुछ पहले से ही पैक करके दिया होता है फॉर ऑल द डेवलपमेंट बोर्ड लाइक यू कैन गो टू द टूल्स एंड यू कैन सेलेक्ट बोर्ड्स लाइक आई हैव चूजन द आर्डिनो उनो बोर्ड तो आर्डिनो उनो बोर्ड उसके बाद तुम्हारे पास आर्डिनो के जितने भी सारे बोर्ड्स हैं लाइक आर्डिनो नैनो मेगा लेनार्ड माइक्रो मिनी इथरनेट and all the Arduino boards are here and once you choose the board all the libraries will automatically download it for that board. Right, for example, in this we can also use a third party board like ESP. ESP is like a third party board which is made by not made by the Arduino, right? So we can also use these type of board for these IDs. So the question is again कि हम बाकी IDs क्यों नहीं यूज करते? तो बाकी IDs यूज करने के लिए हमें बहुत सारी लाइब्रेरीज इंस्टॉल करनी पड़ेंगी एंड ऑल दैट काफ़ी कॉम्प्लेक्स चीज़ें हो जाती हैं. सो व्हेन आर्डिनो ने दिया ही हुआ खुद से तो वाई वी आर नॉट यूजिंग दिस. अब बेसिकली आर्डिनो आईडी के अंदर दो मेन चीज़ें होती है. फर्स्ट वन इज वॉइड सेटअप, सेकंड वन इज वॉइड लूप. लाइक तुम लोगों ने देखा होगा व्हेन राहुल वाज शोइंग हिज प्रोजेक्ट इन ही वाज शोइंग हिज कोड बट देयर इन द आर्डिनो वॉइड सेटअप के अंदर पिन मोड टाइप का कुछ लिखा हुआ है. तो पिन मोड इज बेसिकली लाइक यू आर मेकिंग अ डिश तो उसके लिए तुम लोग पहले इंग्रेडिएंट सॉर्ट आउट करते हो. तो वैसे ही पिन मोड होता है एक आर्डिनो के लिए कि तुम्हें कौन सी पिन यूज करनी है. So the pin you are going to use, you have to mention it. Like for example, in this, I am going to use pin number 12, and first you have to address the pin. Then you have to tell for what purpose you are using. You can use it for input, or you can use it for output. तो लाइक अगर तुम लोगों को उसके अंदर से वोल्टेज देनी है लाइक इन द रिले वाला प्रोजेक्ट था व्हेन वी हैव टू गिव द सिग्नल सो वी आर यूजिंग द पिन्स एज एन आउटपुट मोड. फिर व्हेन वी वर यूजिंग like LDR type or other sensors,
Yep.
so we are using the pin in the
Raj,
input
so
mode.
just a minute. So can you increase the font size? Just control and scroll up in the mouse. It works. Yeah.
Like,
So it's
now
fine.
it's
Yep.
okay.
Yeah. Yeah. Thank you.
So this is the basic pin mode function, right? So in the void setup we have to set up the pins कि हमें कौन कौन सी चीज़ें यूज़ कर रहे हैं. लाइक इफ़ यू आर यूजिंग सीरियल मॉनिटर इज लाइक तुम लोग जो भी डेटा ले रहे हो तुम्हें अगर अपने कंप्यूटर पे ही उसको प्रिंट करवाना तो यू नीड अ सीरियल मॉनिटर. तो ये आर्डिनो आईडी के अंदर सीरियल मॉनिटर भी यहीं पे पड़ा होता है. यू कैन जस्ट क्लिक इट. So like it is not showing anything. So we can use serial monitor from here, and then there are many other cool features like you can select a sketch and you can use the examples. अगर तुम लोगों को सीधा आर्डिनो यूज करना है स्टार्टिंग से ही तो तुम लोग जस्ट यू कैन यूज दिस examples like you have to use this basic a blink example. You can just click it and we'll get this a new window in which we'll get the blink example. तो ब्लिंक एग्जांपल के अंदर यहाँ पे लिखा हो डिजिटल राइट एंड डिले कोड. These are some of the native functions of Arduino, and you can learn all that from the Arduino website. Arduino website पे जाके रेफरेंस टाइप ऑफ उनकी डॉक्यूमेंटेशन दी होती है वहीं से तुम लोग आराम से पढ़ सकते हो. So there are many other features of this ID like in edit option you can copy as an HTML, paste code, increase, decrease font sizes. In the sketch you can include libraries, various libraries for the various boards. You can change boards and you can also change the processors like in AVPR programmers and all other things. So this is the basic of this Arduino IDE. बाकी तुम लोग इनको इंस्टॉल करके थोड़ी सी एग्जांपल्स खुद चला के दिखाना. And also this feature is like if I write mode in the different spelling तो ये color up नहीं होगा. And if I write in right तो आर्डिनो रिकॉग्नाइज दिस फंक्शन। तो ये ऐसे करके थोड़े से इसके फीचर्स हैं जो कि हमें कोडिंग करने में काफ़ी इजी हेल्प कर देते हैं। तो यू कैन डाउनलोड इट फ्रॉम arduino.cc and all that, also from Microsoft Store. Okay, so this is all about the Arduino IDE and also some of the features.
So, as we all saw this code and this circuit, here we were not able to stimulate it uh, accordingly because because for AND gate we have to press both the buttons together, which was not possible. So let us try to make it as an OR gate. So can you drop? Can everyone
Yeah.
drop a code
So
in Discord for the OR gate?
uh, let me like go through the physical demo for this thing. So,
Okay.
and one thing, yeah. So do not purchase Arduino from like online Arduino.cc store, because the original one costs like around 2,000 or something, but in local market we will able to get it like around 400 or something. So you'll get it for cheap because it's all the same and open source, right? Am I audible or am I not audible like clearly? Just let me know. There are comments to increase the sound. Yeah, so let's go. So this is the code. Yeah. So can you see my screen? So we have two buttons, button one and button two. So button two is for pin number four. Let me just like show you the diagram that we're using. So just let me show it to you live. So where is it? Just a minute. So it's on. I'll have to just pull up a circle. Yeah, so it stopped. Yeah. So this is something that we're going to demonstrate. Yeah. So let's see how the programming and the wiring part works. So the one switch, this particular switch turns off the LED, and this particular switch turns on the LED. Right. So like I can turn both off. Yeah. I can play with it essentially. So let's see the code once. It's really simple if you go through it logically. Let me read out some comments first of all. Yeah. So we have two buttons. Button one is for pin number four and pin number two and pin number four essentially, right? And we have two LEDs. One is for 18, 8 and 12. So what we are doing is we have two buttons and we are taking inputs from two buttons. We are reading their inputs. Like I have wired it in such a way like whenever the button closes, it makes a like circuit complete. So the pin on the other side of the button, it gets some voltage that wasn't there in the first place, right? So when there is more voltage than on that side, the pin goes high. So this is the void setup. We are using buttons to take input, and we are like displaying the output using LEDs, right? So we are using state one and state two. So these are essentially the states of the buttons. So this loop goes on and on until the Arduino is plugged in. So the button state one is digital read button one. So we are reading button one. So let me see which one is the button one. So yeah, so the button one, if it is high, so it will make the LED high. So button one is this one, the green one. This one. This is the button one, and this is the button two. Yeah. So let's move back to the code. So if the button one is high, so if I have pressed the button, it will become high essentially. And what it will do is it will turn the LED on. Else what will happen, the LED will turn off. We'll need to have the else clause, because if like we do not have this particular thing right here, once we press the button on, LED will remain on till the Arduino is in power. Yeah. So this is button state 2. What this does is this maps the second button that we have, and if that button is high, if we press that button, it turns off the LED that was already blinking, that was already on, right? So this is the code, and this is the demonstration. This thing, right? So let me like focus it once and zoom it for a better view. Yeah, so it's focused. No, I don't need flash. Zoom. Yeah, so you can see it clearly probably. So this white thing, this is a breadboard. This is used because what earlier was used was this thing. Yeah, this is a prototype board. So you can essentially use wires, solder it on there using a soldering iron, and make a project. But before moving to this particular thing, because if something goes wrong, you'll have to desolder it or start from scratch. So we use this. So this is something like a breadboard because it's fluffy like a bread. So it has this pins, this holes. This has like 840 holes in total. So these two rails, these one, and these are used for power. So these are horizontally connected like this. So all these are shorted this way, right? These one, but the middle ones, uh, yeah. So these ones are connected this way. So if I like plug a wire, if you can see this, if I plug a wire in this particular slot, in this slot, and if I plug one more wire, let me grab a cable. If I plug a wire in this particular slot, yeah. So these both are at same potential right now because this is shorted horizontally, and these are shorted in this manner, like this. Now these both two are at same potential. So this is essentially a breadboard. So this is a 5-volt supply, like input the high voltage of Arduino. This one is the ground. This one right here. This one. So 5 volts and ground. In between 5 volts, what we are doing is we have added a button, right? So this is the cable that goes for the input. This cable goes into Arduino input in the pin number 2. Let me show it to you up close. So yeah, let me focus it once. Yeah, so if you can see this, this is pin 2 right here. So pin 2 is connected to this blue wire. So similarly, this purple wire, this is connected to pin 4, right? So pin 2 and 4 are described as input pins in our code. Yeah, button 1 and button 2. These were 2 and 4. And we have LED 1 and LED 2 as output. So let's see where are LED 1 and LED 2. So if I can focus it right. Yeah, so we have LED 1 and LED 2 right here, like 8 and 12. This is the 8 and this is 12. We can use any pin in this row for this particular demonstration. So whenever I press this button, let me focus it once again. It keeps going out of focus. Yeah. So when I press this button, yeah. When I press this button, this wire becomes high. This wire becomes 5 volts and gives a high signal to the board. Then the board is in the loop, and our code realizes that this particular button has become high. So it will give a signal to this wire, the output wire, to become high. So this becomes high and LED glows. But this here LED is already high, right? And because let me show you in the code, because in the else part we are doing it high. Just a minute, this part, yeah. So this is already high. When we press the button, it makes it low. So that's essentially how things work. So I'll just share this code to all the audience, and you can just play around it and just a minute. So yeah, I'll just send this code in the chat box and at the Discord server. You can play around it and modify it, and you can send it to us, and we can like just upload your code that you have written and show you how the things work. So if your code works well, we'll just add you to the giveaway list. Else, the ideas are there to judge you, right? So let me drop in the chat box. So I have just sent the code at the WhatsApp groups. And it's called essentially. Just a minute. Grab it here. Yeah. Just give me hi in the IoT server, and we are good to go. Yeah. Just spamming all the servers that I have. That you can put this. Find it in the journal channel at the DSC server. So, to come up with the code, if you can right now, else we'll just move in with the session. Okay. Yep. Do ping me with all the doubts that you have. Like you must have doubts how we are controlling this stuff and making building stuff out of it, and then we can close the thing. Yep. Do we have any doubts? Here, where is Ravinder? Hey, Ravinder. Hey. So,
Let's see.
yep. I think we can end it right now if we do not have something more to show. Let me show you the Raspberry Pi once if we have time. Do we have some time, like 2-3 more minutes, Ravinder?
Sure, sir. We are done with our things.
So, just a minute. Let me grab my charger. Mute. Yeah. Yep. So, we have plugged in the HDMI cable. We'll just plug in power right here to the Arduino initially. And yeah, so the power is on. HDMI cable is going for display signal. Let's plug in the mouse and keyboard. So let's plug it in. Yeah, so keyboard mouse on, and the Raspberry Pi is working. Yeah, so it will boot up right now. Let it just get started. I hope it works. Yeah. So this little thing is a computer in whole. So it's working and giving me desktop, and I can play with it around essentially. I hope like it won't take much time. Yeah. So we are in. So this is the desktop. Just believe me or not, like this is the whole thing that is working, and like we can do anything. We can do programming. There are IDs. We can also program Arduino using Raspberry Pi. So we can use Python and let's just play around. Yeah. Print goodbye. Yeah. Yeah. So essentially we're done. Yep. Thank you, folks. Thanks for joining. And I hope it was a great session, like something unusual than the normal ones that we already have. Let me just plug it off. Thank you, folks.
Thank you, everyone.
The team can end the session right now.
Thank you, everyone.
If you have doubts, like you can ask and we can just end the session.